Hello, everyone, and welcome to session 9, 3D ToF Machine Vision Keeps Mobile Platforms on Track. I'm here joined with Mohammed Al-Bayrak, and he is joining us as an applications engineer for 3D compact systems. As well, we're going to be joined by a partner, Magazino, and Raphael Wering is his name. We'll do a little introduction right in the beginning. This is about the, oh, he's right there. I can see him already. Hi, good to see you. This is going to be about the SICK Visionary T Mini for navigation support and collision avoidance. I'm going to hand it over to Mohammed, and you can start us from there.
Thank you, Patrick.
Sure.
So I will start with a short introduction by myself. So my name is Mohammed Al-Bayrak. I'm application engineer at 3D Compact System and also responsible as a product manager for the Visionary T Mini, which we will introduce you today in this session together with one of our first customers and Raphael Wering from Magazino. So Mr. Wering, maybe you can introduce yourself shortly.
Hi, I'm Raphael Wering. I'm from Magazino, from Munich today. I'm with Magazino since 4 years, and since almost 9 months, I'm now the product manager for Soto, our newest product for the automatic supply chain to transport KLTs to the supply lines.
Good to have you here, Raphael. Thank you for participation. And I will continue then with a short agenda introduction. So we will first introduce, of course, also Magazino itself, and then we will concentrate more on the use case of Magazino and how the 6 sensors at the Soto are used. There are also different other sensors available, and also we will then focus more on the Visionary T Mini. We had the chance to visit Magazino shortly recently and took also some footage, which we'll show and share with you also here in this presentation. So 3D Compact Systems, there was already a session today at 11:30 introducing the application about the pelletizing with the Visionary S, the active stereo camera. It's also here again the topic 3D snapshot devices, so meaning simultaneously capturing the 3D data from a scene. And we have different product families, the Visionary T based on time-of-flight technology, the Visionary B for passive stereo, and also the Visionary S for the active stereo illumination. And today we will focus on the Visionary T Mini, which is our newest product, which is soon to be released. And here you see some highlights of this product. So the device itself has a very compact design and the housing. It's approximately 80 by 80 by 80. And of course, no moving parts inside, no scanning parts inside. So it's a snapshot device, a real snapshot device, which comes naturally by a very high robustness against shock and vibrations. And due to the state-of-art system design and illumination technology, it comes also with an unrivaled precision. Currently, very reliable data. And of course, we always focus to build industrial design and industrial sensors. So it's a very rough and harsh product, and very good and important to mention the data quality itself. It's optimized for moving applications and for scenes with very high dynamic insight, so meaning very bright objects on the scene or very dark objects on the scene at the same time simultaneously. During the development, of course, we always are interested to involve our customers as well. And here we had the chance to provide Magazino, one of our first prototypes, and could gain their trust and had the chance also to place our product in the application, and we are happy that it worked out so well. So I would like to ask Raphael, can you please introduce Magazino and
Yeah, thanks. So Magazino, we are a robotic startup company right in the heart of Munich. We develop and build intelligent mobile robots that perceive the environment and then make their own decision based on what they perceive with their sensors. Our autonomous robots work alongside humans and make processes in the e-commerce, in fashion, and in the production logistics, which is the part where our Soto comes in play, more flexible and more efficient than ever before. Altogether, we are 110 employees. We are the largest advanced robotics team in Europe, and our investors currently are companies like Jungheinrich, Körber, Zalando, and Fiege.
Thank you. So let's dive into the use case and the application itself. So currently, I'm not sure which presentation is shown there, so maybe the Reggie shortly. Thank you. So which application was the Soto developed for? Can you give us there a short introduction on that?
So the problem is that production lines itself are extremely highly automated. But in contrast, the upstream supply of the replenishment is still a very manual process. And the reason for this is the environment changes and it's not as predictable as a simple conveyor belt. And Soto ensures the replenishment of materials in KLTs from the warehouse to the assembly line. So Soto picks up, transport, and places the small load carriers completely autonomously, parallel to humans working in the same environment. And as far as we are concerned, Soto is the only solution we know so far that combines these three steps. So the picking up of an item, transporting of multiple items, and then putting down the item near the assembly line in one vehicle. And so this makes an end-to-end automation of the KLT supply possible.
Thank you. Here's the footage for that. So I just wanted to give you the chance to describe it concretely. But feel free to give some comments here as well.
So here you see the Soto driving around in our testing environment. So no real production environment there, but you see Soto as it drives in. It can dock to a shelf, and then at the shelf, it can grasp up KLTs. It perceives the KLTs, sees the barcodes, recognizes the barcodes, and only picks up boxes where there is an order for. Then it puts it into the backpack. In the end, Soto can store up to 24 KLTs in its backpack, so it also can transport items for longer time and still have a good value.
Great, thank you. Very great machine. So, as I said, I had the chance to be there on site, and very complex and really nice mobile platform. And which customers are typically the user of such a Soto?
So typical customers are production companies that have the largest share of their material supply in KLTs from the warehouse to the production line. Examples are the automotive industry with the OEMs, but also the tier 1 to 3 suppliers. But we also have typical customers in household appliances or the electronic markets. Where we are not working in for now is the whole area of frozen goods, food, and in clean rooms.
Mm-hmm. And do you have, so what's the current status of the product? Do you have already some first customers where it's already driving around, or what's the status there?
So we have a first pilot customer. It's Vega Grieshaber in the Black Forest, so not that far away from SICK. And we are also currently in discussions with a lot of other companies. We offer different phases of getting to know us and our product. So you can start with a small requirement study where we visit you on site, and then together with our project and process engineers look if the application is suited, what has to be changed. Then starting in 2022, we will have a so-called test and try, where you can rent one of our Sotos for 6 to 8 weeks. And then after a short training, you can use it on site in a small sandbox where you can then test if all the KLTs work, if the handover solution works. And then in the end, of course, there is the idea to start with a pilot project and then going into the scaling of the fleet. And so whenever you are interested in this, feel free to contact us.
So when we were there, so there's the next footage, which I will share with you. And I noticed there are, of course, more than only the Visionary T installed on the machine itself, on the Soto. Can you give us a short introduction or tell us a little bit more about the sensors which you use?
So yeah, for navigation, we will start using the Visionary T Mini. But of course, we also have laser scanners from SICK on there, as you see here in the footage. We use the whole FlexiSoft solution for all our safety sensors, which also include incremental encoders to supervise the movement of our vertical axis. And also we use inductive and magnetic safety switches to see in which direction our gripper is currently rotated, so that we always can ensure that we can operate safely alongside humans.
Focusing on the Visionary T-Mini, so what's the job of the Visionary T-Mini?
So the job of the Visionary T-Mini is to identify and avoid obstacles that are not at the plane of the laser scanners. For detecting obstacles at laser scanner heights, the laser scanners are perfect, but there are different other obstacles around that are not there at laser scanner height, and so we then use the Visionary Mini T to detect them and then plan our path around it.
Yeah. So I just prepared also a slide with some data from the Visionary T, but maybe you can tell us the challenges which is there in your application for the device.
So we have more or less 4 different obstacles we want to detect with these cameras. For one, it's obstacles that are just above the ground, like forklift forks very close at the bottom, or screws of infrastructure elements. The second obstacles are obstacles that hang from the wall, something like fire extinguishers. The third category is obstacles that float freely, so something like shelves where the pillars are far away from each other and not be detected from the laser scanner, or signs or bar stock on pallets. And the last category we would like to detect with this are so-called negative objects like stairs or ramps that go down.
And how are you solving this application? Are you doing this all by yourself, by your team?
So we will use the Visionary T-Mini for this to get the point cloud, and then the point cloud is computed on the computer, and then we get a cost map of where obstacles are, and then we can plan in our software around these obstacles.
Mm-hmm. Great, thanks. So about the Visionary T-Mini, so which benefit does it bring to you, and does it solve some problems for you which you had during the product development?
So one of the most benefits is the compact size, because other 3D cameras that are industrial grade are very, very big, and we could not integrate them into our robot so far. Then, of course, the industrial grade of the camera itself. So we have stable Ethernet connection with it and good mounting points to mount it in a robust way on the robot. Also, the high resolution of the camera is really nice, because then we are able to detect smaller obstacles. And also the high range of the camera is a big benefit for us, because then we can detect obstacles really early, and we can early start to plan around this obstacle and not just break very last minute.
Thank you, Rafael, for all the insight and for sharing this application with us. So I hope you can give us also feedback with the cooperation with SICK. So how was it for you to working together with SICK?
Yeah, so the experience was very, very pleasant. We got, as you already mentioned in the intro, a very early version of the prototype for our evaluation, if it fits. We got also their big support in getting it to run, integrated it into Rust, and so on. So it, all in all, was a really, really great experience.
Great to hear that. I'm really happy that we have the Visionary T on your side, and maybe you can give us some idea what are the next steps for Magazino together with SICK.
So our next version, the Zoto 2.1, will have this camera on board. And so there, SICK supports us on the journey from the first prototypes we built to a serious product. We will also continue using the safety components from SICK. And there I want to thank the whole team of Martin Benz in supporting us there for the last years in getting the safety to the state where we're currently at. And to sum it up, SICK helps us and the Zoto to draw a reliable picture of the environment in the complex world we have to envision as soon as there are humans around.
Thank you. Thank you for this great feedback. And I hope you will stay in the line for the questions part later on. So I will just give you some more insights to the Visionary and the T-Mini. So the target applications, as you saw already with the use case which we shared with you, is of course within the logistic optimization for AGVs, AGCs, object localization, collision warning or navigation support, but it can also be used for static dimensioning of goods, different goods, of course. And again, here it can also be used for the robot applications like palletizing, depalletizing, of course, depending always on the application requirements. But here as well, I want to refer again to the session at 11:30, where we showed you also the difference to the Visionary S. One of a lot of different applications which could be solved with that is also the completeness check, for example, at packaging machines. Now, coming to the main features and the of the device. So as you can see here, as I said before, 80 by 70 by 77 actually are the concrete numbers for the housing. And it has an industrial design. We have a system plug with 6 programmable I/Os for the later available programmable device based on app space concept for the Visionary T Mini. And also we have a M12 communication interface. And very important, the system design. We have latest illumination technology integrated there, and a very, a very good 3D time-of-flight imager, which allows us to build up a really good user experience with this device without changing a lot of different configurations, so with very simple handling of the device itself. And the good thing is that we can stream out up to 30 frames per second. All the calculation of the depth data is done on the FPGA inside the device, and is then streamed via the TCP IP or UDP protocol. On the right side in the presentation, you see some animations with the data of the Visionary T Mini. So on the top side, you see there an example. For example, these boxes. The upper left one is a little bit open, and in the 3D point cloud. And the advantage of the 3D data is, of course, it will show you the height profile or the difference in the height. So it's the added value of the 3D, actually. And in the middle, you see the quickly turning screwdriver with the very black rubber grip and the metal surface in the front. And we can see here clearly that the depth accuracy is so good that we can even differentiate this tooltip in the front from the background. And of course, the fast movements, for example, of my hand waving or turning this screwdriver is perfectly captured in the device, because it captures with a very high dynamic range the frame within less than 10 milliseconds. So it provides you really good and reliable 3D data with, well, almost no blur effects. And that's it for the Visionary T Mini. I hope you liked the session, and I'm happy to hear some interesting questions for you.
Well, you'll be happy to hear, Mohammed. We have some interesting questions, probably for the both of you. I think it's also quite fascinating the amount of data that you can provide into that point cloud information into the system that can be processed by ROS, by the programming language. Quite fascinating. I have a couple of questions. We have, I think, 3 of them, and we do have enough time to handle them. First question is, have the SOTO units been applied in a hospital or long-term care environment?
So I would like Raphael to...
Maybe that's something for Raphael, perhaps. Go ahead.
No, not yet. For now, we focus on the production environment. But if you have a nice use case in a hospital or in a medical environment, feel free to contact us.
Call Raphael. Exactly. That's the answer. No. But I could also imagine this as well. I think the situation could be similar, but maybe there's some other changes to be had. A lot of the time, especially with vision applications, you do need to talk about the aspects of the application. The next question is, what's the maximum response time between the camera and the action of the Magazino robot? I think you mentioned something about 10 milliseconds in the camera, but then you probably have to take into account all the way the actuator or the stopping motion.
So I'm not sure, Raphael, if you know this answer, but I can give a typical value. So I'm also not aware about the reaction time in the Magazino system or on the SOTO system. So the frame or image acquisition itself is approximately below 10 milliseconds. The frame rate is available up to 30 frames per second, so 33 milliseconds could be available for each frame. But the reaction time to receive the first frame can be depending on the network situation. So
if the situation arises,
approximately 50 milliseconds,
okay.
So 50 or 60, 70, so it depends then.
Yeah, with that frequency, if you missed that exact frame, you're waiting 30 milliseconds.
Yeah, exactly.
And,
33 milliseconds and you would have the next one.
I got it. Very good. What is the maximum range? This is something I can ask you.
Yeah. So the device itself can see up to 16 meters. That's the physical limitation of the device. But then it's also depending on the emission properties of the scene. So the application or the device itself is optimized for the range between 0.3 and up to 10 meters in range for objects which has remission properties for infrared, approximately for 90% remission properties. And for dark objects, we are limited there. So then there's at 7 meter stop, but still we perform very well there.
Okay, very good. What other questions? There's a question, when is the camera going to be available?
Yeah. So we are at the last steps actually, but currently the official launch is planned for September, but we are at the state where we also take the pre-orders already and provide chosen customers with the first devices soon,
your hand, though.
very soon.
Yes.
So our current plan is that we will be able to deliver the first devices starting within the next 2 weeks.
Okay, very good. And which applications are in focus is another question that came up. I think we saw a couple already.
Yeah, we had it shortly. So within the logistic optimization, so mainly in the optimization part, where we can provide reliable and high quality 3D data to do the localization of different goods, or to check, for example, also if there's a change in the environment. And that's the advantage of this device itself, because it has also the integrated illumination by itself, so it can also work at very dark environment, for example. And for sure, one of the target applications is the automation of AGVs and AGCs, where, for example, the pallet pockets should be detected or other targets, or also to see the environment, so 3D perception, basically, and to support the navigation.
Okay. One more question, maybe to Raphael. If you're creating this kind of point map of, say, a logistics center, are you monitoring that data to look for aberrations or changes? For example, fire extinguisher is no longer there, or there's a piece of metal from the shelf that's been bent out. Are you doing decisions like that as well?
So we do the decisions in then real time to avoid obstacles that appear and would not have been there before, but we do not continuously track the environment for things like this. Okay. But of course, this could be a feature that some customers might be interested in.
Yeah, I was just imagining, at least personal, my imagination would be perhaps there is a need to take in logistics center and look for perhaps problems in the shelving or missing parts that should be there and things of that nature. But this is something in the future. If you need some suggestions from me, I can come by. You're in Munich. It's a nice city. So very good. Yeah, I think we've got through quite a few questions on this. I wanted to thank Magazino, Raphael, for joining, Mohammed also for getting into detail on the new Visionary T-Mini. Are we taking orders already?
We take pre-orders.
Okay.
Please contact your sales contact.
Very good. No percentages are going to Magazino. Thank you for joining.